Greetings and welcome. I am Mr. Nagengast. We are talking about law of cosines and law of sines for Algebra 2. And we're talking about non-right triangles known as oblique triangles. What that means is there is not a right or a 90-degree angle. Now, we will talk about law of sines and law of cosines. But before we do that, I want to remind you that on my website you can get this PDF file which follows along with these notes. If you choose not to do that, simply pause when you need to write something down or when you need to catch up. So otherwise, these notes are printable for you in a PDF format on my website. Just go ahead and do that now. Again, we are talking about law of sines and law of cosines, and you'll see these are formulas for us to look at. Formulas in which, after using for a while, we'll memorize just by nature. Now you'll see in the law of sines there are two setups, an or. And one, you'll see that the sides, A, B, and C, are on top. And the other one, you'll see that we have the angles on top. Now, depending on what we're trying to find, if we're going to find a side, we will use the first one here. If we're going to find an angle, or a theta, we will use the second one. Law of cosines deals a little differently. That is a formula where we are trying to set up one side. The square of one side will equal everything you see on the right side. Now notice if I have a squared, I have cosine A. If I have b squared, I have cosine b. And if I have c squared, I have cosine c. So I cover or have bookmarked, or at the end points, the a's, and everything else is in between. Now you'll see that if I'm looking for a squared, I then have a b squared plus a c squared minus a bc. So you'll notice that I have a b squared and a b, a c squared, and a c in this formula. And then again I have an a squared and the cosine of a. So I really have two of each variable showing up in some form, whether that's squared, not squared, or as an angle sign. But let's look at this later. We'll come back to it. We're going to look at a couple problems in which we do this. So we have to look at a couple situations. And the situation says, to solve for any non-right triangle called an oblique triangle or oblique triangles, we must have one side and fulfill the following requirements. So a side is necessary. We're always going to have a side. Now the reason we need a side is the following. If I have a triangle like such, and we'll call this A, B, and C, and A is unique from B and unique from C. If you remember from algebra, we have these little marks. We could have a similar triangle that we call A prime, B prime, and C prime that have the same angle measures as the smaller triangle. But the problem is we don't know what the sizes are. The sizes are flexible. So we need one side to hold true to the triangle that we're trying to solve. Now, you'll see that we talk about the use of law of sines, and we will use these when we have an AAS, or angle side. Or an angle side angle. And we also use that when we have a side-side angle. So the S represents a side and the A represents a given angle measurement. So we have two cases in which we use the law of sines. We also have two cases in which we use the law of cosines, the longer, more complex equation. A side angle side where the angle is in between the two sides, or where we're given three sides. And now we'll look at a couple examples. So here's a triangle, and this triangle is generic, doesn't even have to be accurate. Definitely it says draw not to scale, which is often the case. But what is accurate is that if I have an angle B, I have a side opposite little b. If I have a capital letter A, that represents the angle, little a on the other side, and so is true with the C and a little c. Now normally little c marks a right triangle, the hypotenuse. In this case, they don't matter. They're just variables representing sides and angles. So we're going to find the remaining sides of what's been given. And in this one, we've been given an angle A of 70 degrees, a measure of angle C of 65, and A is 24 inches. So if we look at the triangle above, we'll see that we're given angle A and angle C, and the side A is opposite. So we see an angle, angle, side. So I have an angle, angle, side, which is definitely used for law of sines. As I said, these first three examples would be. Now, if we take a look at this one, how do we set it up? Well, we want to find a side. So we're going to find a side. But before we find the side, the easiest to do when given two angles is just to find the other angle. Now, how do we do that? Well, every triangle has 180 degrees, so if I want to find the measure of angle B, I simply take my 180 degrees and I subtract from it my 70 degrees and subtract from it my 65 degrees. Now, what that leaves me is then an angle measurement of 45 degrees. So the measure of angle B equals 45 degrees. Now, that might not look accurate to our picture. It doesn't need to. The picture is only to keep us straight with our A's and opposite sides. So, once I have one solution, I now need to find my sides that I was talking about. Now, the first side I'm going to look for is A. And because I want to find a side, I am going to use this first one here. I want the unknown on top in the fractions. So I'll go back here. I'm going to put my side A I have over sine of A, and that will equal whatever side I want. In this case, I'll choose C, which means I'll have it over sine C. Now substitute in, I have an A of 24, and I have a sine of 70 degrees, and that equals C over sine of C. Well, sine of C is 65 degrees. And now I simply will cross multiply. So what I will have is 24 times my sine of 65 degrees, all divided by sine of 70 degrees. And that will give me my side length of C. If I punch this into my calculator, the first thing I'm going to do is need to make sure that I am in mode of degree. So what I need to do then is I need to type in my problem, and my problem at this case would be 24 times and my sine of 65. Now again, my mode, I'll do a quick check on my mode. I am in radians, so I want to make sure I'm in degree. Hit enter to select that. Go second, quit, back there. And now I'm going to divide that all by my sine of 70 degrees. So if I hit enter, I get an answer of 23.15. So we'll jump back to our other screen. And so what I have is a value of C equals 23.15 inches. Now I'm going to get my other value. My other value is for the side B. And B we found was sine of 45 degrees. And that will equal, I'm going to choose the original given. So I'll pick A again. I could choose side C and sine of 65, but I like to use the ones that were given. So I avoid rounding error. That's rounding error. So I get this, and I have sine of then 70 degrees. Once again, I'll cross multiply, meaning I'm taking sine of 45 degrees times 24 and dividing it by sine 70. If you do that, you'll end up with B equals 18.06 inches. And we found our three unknowns. As I go into the second of these problems, working with law of cosine, or law of sines rather, I find that I have an angle side angle, which is in fact what we cover in law of sines. Notice an angle A and an angle B, and in between these two will be C. So I want to use law of sines. However, I don't have an angle that matches with a side or a side that matches with an angle, which is our requirement. But one will easily see we can find the measure of angle C simply by taking 180 degrees, subtract 57 degrees, subtract 43 degrees from that, and we will end up with the measure of angle C being 80 degrees. So when they give us two angles, whenever they give us two angles, our first thought should be getting the angle that is still remaining. So now we have one piece of our three we're looking for. So we go to the second part, which says, hey, I'm ready to go. I see that I have C here, so I need side A and side B. So I'll find side A. Well, that would put A over my sine of A. Well, my degree is 57 for the angle A. And that is set equal to my C, which is 18.5, all divided by my sine of 80 degrees, which is what we found for side C here. So working this out on your calculator, you'll take 18.5, times it by sine of 57 degrees. Why? Because we cross multiply. And then divide that by sine of 80 degrees. So my side A in this problem ends up being 15.75 feet. Now we have one remaining side to get. That side is side B. Now you may be asking yourself, well, why aren't we using Pythagorean theorem for that third side as long as I have two of them? Remember, Pythagorean theorem is only useful in right triangle trig. And these are oblique. They're not right triangle. So I'm going to set it up the same as before. My unknown I want on top, which is side B. So that is over my sine B, which is 43 here. So 43. That will equal, I can use any, but again, I don't want to use rounding errors when possible. So I will use side C, which is 18.5, divided by the sine of 80 degrees. When I do the cross multiplication then, I will punch into my calculator 18.5 times sine of 43 degrees, all divided by sine of 80 degrees. If I do this correctly, remember where I need to put parentheses, I will end up with B equals 12.81 feet. And there we have our first video. I'll continue on in video 2 with the rest of the problems.